We're asked to use the first derivative test to locate the x value of all extrema. Classify it if it is a relative max or min. Alright, very similar process to what we've seen before. As always, first derivative test, if we're trying to find extrema, we have to find the first derivative. The first derivative of this function, luckily it's just a polynomial, so we're just going to use the power rule. H prime of x will equal negative 6x squared plus 12x, and then minus 0 because the derivative of the constant is 0. So here we are with our derivative. Now, what do we need to do? We need to test for two locations. The first location is there any place where the derivative is undefined? Is h prime undefined? And the answer to that is no. There's no value that's going to make this thing undefined. There's no fractions, there's no square roots, there's no logs, so we're good to go. Nope. We then have to check, is h prime equal to 0? And so we have to set it equal to 0. 0 equals negative 6x squared plus 12x. I see I can factor an x out of both of these terms, so I get 0 equals x times negative 6x plus 12. And using the zero product property, I can say x equals 0, or negative 6x plus 12 equals 0. The left side's already done. Here, I'm going to add 6x to both sides. 12 equals 6x, so x equals 2. Alright, so now I have two critical points to look at. X equals 0 and x equals 2. What are we going to do now? We're going to make our chart. That's right. And so, let's make our chart. Remember, it's x and h prime of x. Alright. In these skinny boxes, what I'm going to put are the two values we found, 0 and 2. Over here, negative infinity to 0. Over here, the range is 0 to 2. Sorry, the domain is 0 to 2. And over here, the domain is 2 to infinity. And we want to figure out what's happening in each of those locations to our derivative. For h prime of x, we're going to plug in really, really big negative values. So I'm just going to say h prime of negative big equals negative 6 times negative big squared plus 12 negative big. And so here we're going to get negative big squared is just going to give us positive value, so it's going to be negative 6 times positive big minus 12 big, right? But here's the thing. A negative minus a negative, it's just going to be even more negative. So this is going to be negative. So we can write that in, negative. We already saw that h prime of x when it's 0 is 0, and also for 2, it's 0. Oh dear, I erased everything. There we go. It's 0. Now we want to test between 0 and 2. What's a great number between 0 and 2? 1. Awesome. So we're going to do h prime of 1 is equal to negative 6 times 1 squared plus 12 times 1. So that's negative 6 plus 12, which is 6, which is positive. So over here, we're going to label that's positive. And then 2 to infinity, we can plug in any number. I'm just going to say big just because it helps me. The final bit, h prime of big equals negative 6 big squared plus 12 big. Over here, this negative 6 times big squared, this is going to be negative 6 times big. I'm going to write it in capitals because that big squared is much bigger than just big by itself. So because this negative is bigger in magnitude than this one, our final answer is going to be negative. Even though we're adding 12 plus a big number, adding that is not as much as multiplying by this negative 6. So we end up with a negative value here. So what does that tell us? At 0, we see that the derivative goes, and I'll do this in green. At 0, we see that the derivative goes from negative to positive. And so, since f prime goes from negative to positive, we're looking at something like this. Negative to positive, that means we have a minimum. And then, I'll do this in red. For 2, since we go from positive to negative, that means we have a maximum. And so our final answer, just to write it all out, and I'll do it in those two different colors because I already did that, would be there is a minimum at x equals 0 because f prime goes from negative to positive. And then also, there is a maximum at x equals 2 because f prime goes from positive to negative. Again, the goal of this always is to find the derivative, find the critical points, set up your chart, and then test for points to figure out what's happening around those different locations.